Imagine humankind effectively colonizing the Red Planet, and you're one of the first people to brave this challenging journey. During the long flight, you entertain yourself with the thoughts of landing on Mars, getting a nice piece of land, building a house. Wait. The problem is you can't own anything in space. Broadly speaking, no one can own space. But this issue becomes more complex than that once you start looking into the particulars. Space is governed by a special agreement called the Outer Space Treaty. According to this treaty, outer space, including the moon and other celestial bodies, can't be subject to national appropriation, even by means of use or occupation. In other words, no nation can declare itself the owner of any part of space. So, that piece of land on Mars can't be yours. Space is declared to be the province of all humankind, but the contents in space are a different matter. For example, you might have a right to occupy a certain orbit. It means that you can place and keep your satellite in that orbital slot. Plus, when a nation registers its space object, it gets the right to exercise exclusive control over it. So, if one country built a moon base on the surface of Earth's natural satellite, this base would belong to this nation. But no one would be able to claim ownership over the land this moon station would stand on. But then, how about asteroid mining? Asteroids are rich in minerals, in particular, such metals as iron, nickel, gold, platinum, magnesium, palladium, and many others. According to NASA estimates, the value of asteroids that we could potentially exploit for resources could be worth as much as $700 quintillion. And a quintillion is a number with 18 zeros. Who would be the owner of all that wealth? Well, the Moon Agreement obliges the participants to establish special procedures to control the exploitation of the natural resources of the Moon and other space bodies. But so far, it's still a bit unclear what rules this process will follow. In total, there are 5 international treaties related to space law. They're all overseen by the United Nations Committee on the Peaceful Uses of Outer Space, UNCOPUOS. You've already heard of the Outer Space Treaty. It's the foundation of international space law, and here are its principles for space exploration and operation. First of all, space activities should benefit all nations. Any country can actually explore orbit and beyond. There can be no claim for sovereignty in space. No dangerous weapons are allowed in orbit and beyond. The Moon, the other planets of our solar system, and other celestial bodies can be used solely for peaceful purposes. Any astronaut from any country is considered an envoy of humanity, and all other nations that are the participants in the treaty have to provide them with all possible help when needed. It includes an emergency landing in a foreign country or at sea. Also, each of the countries that signed the agreement is in charge of its space activities and must provide constant supervision. And finally, nations are responsible for damage caused by their satellites and other space objects, and must prevent space contamination. Now, even though nations can't lay claim to space and its resources, are there any constrictions determining who can keep stuff from space that landed on our planet? For example, in July 2022, space debris from SpaceX fell in a farmer's backyard in the Snowy Mountains. If this is the case, space junk must be returned to the country where it came from. But what if it was a meteorite carrying potentially valuable minerals? Specialists say that if this space traveler lands in your own backyard, as opposed to the property you rent, then you become the owner of this meteorite. But if you find the same meteorite on public land, you won't be able to keep it, because meteorites are classified as protected objects under the Protection of Movable Cultural Heritage Act, 1986.
You're hovering about 18 miles above the surface of Earth and enjoying the best view of our planet. Whoa, that's a starfall! Make a wish. And that bright dot that's moving very fast is the International Space Station. And then, the waiter brings you a drink. Wait, why is there a waiter? Well, the thing is, you're on a tourist spaceship, and very soon everyone will be able to fly into space with giant balloons. This is Neptune. It's a round capsule with panoramic windows and a 360-degree view. It can take on board 9 people in comfortable seats, including 8 passengers and 1 pilot. It also has an underdeck toilet. As the manufacturers say, it's the toilet with the best view in the universe. There's also a luggage compartment for tools and scientific equipment in the roof of the capsule, a Wi-Fi connection that will even allow live streaming, and there's a bar with refreshments. Space Perspective, the creators of Neptune's plan to price passenger tickets starting at $150,000. And there's no rocket engines, are there? This thing will go up thanks to a giant balloon the size of a football field. Let's move to the launch pad. Passengers enter the capsule. Engineers fill the balloon with hydrogen. It's lighter than air, so the balloon begins to take off. When the thrust becomes sufficient, the capsule with the passengers takes off from the launch pad. The journey begins. The capsule and balloon go up at 12 miles per hour. That's twice as slow as a person can run, and 2,000 times slower than a conventional rocket takes off. So you won't experience hard overloads, vibration, and noise like you would on a conventional rocket. So you're already at 45,000 feet. It's almost halfway there. This is where commercial airplanes fly. This is the frontier where the weather ceases to exist. No clouds, no wind currents or turbulence, but no oxygen either. You'd need an oxygen tank to breathe here, but the Neptune capsule is airtight, so you keep climbing. You also notice that the balloon has grown up several times. This is because we filled the balloon with hydrogen at 0 altitude. The hydrogen was putting pressure on the balloon from the inside, but the air from the atmosphere was putting pressure on the balloon from the outside. But the higher up you go, the less air there is. Hydrogen continues to pressurize the balloon from the inside, but now nothing is stopping it from expanding. So we need a very dense material that can stretch for the balloon. Humanity launches such balloons with weather probes all the time. They take off and get bigger as they ascend. But at extreme altitudes, the balloon material can't withstand the pressure, and it pops. The weather probe falls to the ground. We don't want the capsule with people to fall, so Neptune won't take off that high. But in case of emergency, Neptune has a parachute for safe landing. It's already deployed, and it's attached to the rope that goes to the balloon. So in case of unforeseen events, the parachute will instantly open, and the capsule will begin its slow descent. The entire takeoff procedure lasts 2 hours, and you reach the 100,000 feet mark. In human history, only about 20 people went to the stratosphere by balloon. The capsule hangs in the air. Now you and all the passengers have 2 hours to admire the curvature of the Earth, take endless selfies, and relax. You can even see a blue stripe over the surface of the planet. That's our atmosphere. And if you look up, you can see the most beautiful starry sky of your life. Because there are no clouds or light pollution from the big cities at this altitude, and you can see the stars in all their glory. For the same reason, we send our telescopes to this altitude. 2 hours have passed. It's time for the descent. This procedure is slow and gentle too. The balloon is lowered. Atmospheric pressure begins to press on it again, and it shrinks in size. The capsule will land on the water. It has a splashdown cone at the bottom for this purpose. This thing will help dampen the impact on the water so that everything happens softly and smoothly. 2 more hours of descent have passed. The Neptune touches the water. Now a ship is approaching the capsule. It takes the passengers on board and takes them to the shore. It also takes the capsule itself on board for relaunch into the stratosphere. But the balloon itself can no longer be used for a new trip. As soon as the passengers touch the ground, their journey is over. The first person to ascend to the stratosphere in a balloon was this Swiss man, Auguste Piccard. He designed this round gondola. It was airtight and could take 2 people on board. The gondola was attached to a huge balloon as big as a basketball court. As with Neptune, the balloon was filled with hydrogen. In May 1931, Auguste Piccard and Paul Kipfer began their flight. As they gained altitude, they discovered several problems. The airtightness of the capsule was bad. Air would escape from the capsule, but they were able to fix the problem. They were climbing higher and it was getting colder outside, but the temperature inside the gondola reached 100 degrees Fahrenheit because the crew couldn't control the air release valve, so they felt like they were in a hot desert. Auguste's gondola reached an altitude of 51,775 feet, only 16,000 feet higher than commercial airplanes fly now. And 17.5 hours after launch, Auguste landed back on the ground. During this and other flights, the scientists collected a lot of data about the wind in these layers of the atmosphere and cosmic rays. He was also the first person to send a radio signal to Earth from such an altitude. Later, Auguste Piccard used the idea of a fully airtight gondola to dive to extreme depths. He created a bathyscaphe, capable of descending to the deepest point on our planet, the Mariana Trench. Even though the Neptune is much more advanced, it still can't fly into space. It's not even close to it. So this is where Auguste Piccard was able to fly to. Here is the maximum altitude of the Neptune, but space much higher. This is the Kármán line, about 62 miles above sea level. Humanity considers this to be the boundary of our planet, so the tourist in the Neptune capsule won't even be able to feel weightlessness. But if you want to become a space tourist and dance in zero gravity, there are a few more options for you. This is a crewed, suborbital reusable spacecraft. The journey starts on a regular runway, just like a commercial airplane. Here you can see the unusual White Knight 2 aircraft. It's as long as a tennis court and consists of 2 fuselages. Because of this, it has a wingspan as wide as a soccer field, and our Spaceship Two is attached right between these fuselages. So, White Knight 2 takes off like an ordinary airplane and reaches an altitude of about 12.5 miles. Then Spaceship Two undocks and begins an independent upward flight. This small spacecraft is the size of a swimming pool. It's controlled by 2 pilots and carries 6 passengers. Ignition. The rocket engine is on, and the spacecraft begins to gain altitude. The pilots and passengers have reached about 282,000 feet, almost 3 times higher than the Neptune balloon. The passengers were able to experience weightlessness for a while. Then the Spaceship Two began to land. The pilots didn't start engines anymore, they just glided in the air. Then the spacecraft released the landing gear and landed on the runway like a regular airplane. The creator of this company, which owns Spaceship Two, plans to carry out such tourist flights into space more often. The ticket for such a trip will start at $450,000. That's 3 times more than the flight on the Neptune balloon. If that's too much for you, we have another option for flying into space. This is the New Shepard spacecraft. This thing consists of a propulsion module and a crew capsule. It launches just like a conventional rocket, vertical takeoff, fast acceleration, and high overloads. The propulsion module helps the capsule reach a speed of about 2,230 miles per hour. At that speed, you could cross the United States from coast to coast in just 1 hour. The booster rocket climbed to an altitude of 65.7 miles. At this point, the crew capsule undocked and reached an altitude of 66.5 miles. The 4 passengers on board at this point felt weightless for several minutes. At this time, the launch vehicle descended to the ground and then made a successful landing. A few minutes later, the crew capsule began its descent. It launched 3 parachutes for braking. Just a few feet before touching the ground, the capsule makes a quick launch of the rocket engines to slow down completely and make the landing as soft as possible. You can become a space tourist and experience weightlessness on this rocket for only $250,000.
Humanity will once again visit the Moon. The mission is planned for 2024. In this crew, we'll see the first women step on the Moon. The main goal is to establish a lunar base for continued research that will help NASA prepare for an upcoming mission to Mars. Has been planning a crewed flight to the Red Planet set for the 2030s. Robotic rovers did a good job exploring the Martian surface, but astronauts will have to dig deeper to find evidence of water and any fossils proving microscopic life was once possible on our planetary neighbor. New data on Earth-like planets. Since its launch in 2009, the Kepler Space Telescope has discovered lots of exoplanets orbiting distant stars. Some of them have an Earth-like mass, composition, and orbits. NASA plans to launch a new generation of telescopes in the 2040s. They'll help us find real twins of our planet and even get pictures of their surfaces. The return of Halley's Comet. It'll be another 41 years before we once again see the most famous comet in the sky. Halley's visits us every 75 years, so some will manage to see it twice in their lifetime. The longest solar eclipse. 166 years from now, I'll still be around then. The Sun will go dark for 7 minutes and 29 seconds. This is pretty close to the predicted maximum. It'll also be the longest eclipse human civilization has ever witnessed in its 10,000 years. Arrival of the most notorious asteroid. 1950 DA was once the most probable candidate among near-Earth objects we know to actually strike the planet. Fortunately, the chance was later estimated to be not even 0.1%. It'll most likely pass by on March 16, 2880. Mark your calendars. And it'll become a solid evidence that we're safe for a while. The asteroid is more than a mile in diameter, enough to take out life on a planet. A new North Star? The Earth spins like a top. Watch one of these toys closely, and you'll see how its tip starts to draw circles in the air. The Earth's axis, an imaginary line going through the poles, goes full circle once every 26,000 years. It points at different stars along the way, thus changing the North Star. By the year 3000, the Gamma Cephei star will share this title with Polaris, as the Earth's axis will point right between them. The first near-Earth supernova. Antares is the 15th brightest star in the night skies. It's also an old red supergiant, 12 times larger than the Sun. Stars this massive age to a point where they collapse in on themselves, producing huge supernovas. For Antares, this will happen just 10,000 years from now, which is nothing for a 12-million-year-old star. The resulting burst will be too far away to affect life on this planet negatively, but the light show will be visible here on Earth even during the day. Message to the universe. Delivered. Arecibo is the encoded message describing humanity, life on Earth, and the advancement of our scientific knowledge. It was broadcast from the Arecibo radio telescope and aimed at the center of the M13 cluster, 25,000 light-years away from us. In 25,000 years, it'll finally reach its destination. A new closest star. About 36,000 years from now, the Ross 248 star will become our new closest neighbor. It'll be just 3 light-years away from us and overtake the title from Proxima Centauri, which is a bit more than 4 light-years away. Ross 248 will remain the nearest star for around 9,000 years and then move away once again. So, you didn't like the neighborhood or what? The first interstellar human-made object. In 40,000 years, Voyager 1 will reach a point within 1.5 light-years of the Gliese 445 star. It successfully reached interstellar space in 2013. But, unfortunately, it won't be able to power up any of its systems somewhere beyond the year 2025. Voyager 1 has a message too, a recording of greetings in 55 languages, music from classical to rock and roll, and sounds of the Earth's wildlife. A bare Saturn. 100,000 years from now, Saturn will lose its beautiful rings. It'll happen gradually over time as the planet's colossal gravity pulls rocks and ice from this belt floating around it. They'll all eventually fall and get crushed and burned by Saturn's atmosphere. Well, how rude. The ring system is in the middle of its life cycle, so we're incredibly lucky we got to see it in its full glory. The most frightening supernova. The WR-104 star will burst into a supernova in 3,000 years. This star is 75,000 light-years away from us, and the blast won't touch us at all. But there is a small chance it'll also produce a gamma-ray burst in the process. If this stream of energy happens to aim right at us, it will negatively affect life on Earth. Good news? Scientists say that's very unlikely. Colliding moons. The moons of Uranus are part of a highly unstable system. Some of them have orbits that cross paths. Uranus already has 2 rings of debris from past collisions of its natural satellites. Desdemona and Cressida will crash into each other in the next million years and produce new rings. A star too close for comfort. The rogue Gliese 710 star is approaching our solar system, and it will get just 1 light-year away in 1.3 million years. This won't have a major impact on the planets, but it could disturb the so-called Oort cloud, which surrounds our solar system and is full of comets. From Earth, the star will look like the brightest planets we see now, and we'll see many more comets in the skies. The closest star to ever go supernova. Within a few million years, the Spica star, which is only 240 light-years from us, will burst into a supernova. Supernovae are a problem for life when they're 3 times closer than that, but the supernova itself will shine in the Earth's skies as bright as a full moon. A time capsule for future generations. The Lagos 1 satellite was launched back in 1976 to gather information about the exact shape of the Earth and tectonic plate movement. But it also contained information about civilization on Earth at the time. It'll re-enter our atmosphere in 8.4 million years. If humanity is around then, they'll learn how life on Earth was in our time. Well, at least how it was some 40 years ago. Rings for Mars. Mars' moon, Phobos, orbits really close to the surface, and it continues to get 2 feet closer every century. 50 million years from now, it'll collide with Mars, resulting in a massive amount of debris going into orbit and forming a ring system around the red planet. Oh, can't wait for that. Days on Earth will get longer. No, really? 1.4 billion years ago, the Moon was much closer to our planet. It made the Earth rotate faster, so the day was only 18 hours. The Moon is continuously moving away from Earth. In 180 million years, we'll gain 1 extra hour. In a little over 2 billion years, a day on Earth will be 36 hours long. No more solar eclipses. 600 million years into the future, the Moon will move away from the Earth too far to cover the Sun during eclipses. Those will become ancient relics. The Sun will get too bright. It'll take about 1 billion years for the Sun to raise its luminosity by 10%. This will be devastating for planets in the solar system, and life on Earth won't be possible beyond this point. By then, our species will likely have found a new planetary home. The Sun will swallow the inner planets. In 5 billion years, the Sun will begin to evolve into a red giant, growing hundreds of times its current size. It'll swell up so much, it will eventually engulf Mercury, Venus, and possibly Earth. The new Goldilocks habitable zone may shift to the orbits of Jupiter and Saturn. This process will take a bit under 3 billion years until the Sun reaches its maximum size. After that, our star will shrink into a white dwarf. The most epic event ever. Around the same time our Sun is swelled up, the nearest neighboring galaxy, Andromeda, will come too close to the Milky Way. If we could watch our galactic neighbor at this time, it'll get larger and larger as it approaches. Then, the 2 galaxies will start to merge. Bright blue stars will burst into life. New constellations will form. The 2 spiral galaxies will now be a single giant elliptical one. Wow, I've set an alarm on my smartphone so I don't miss it.